Welcome, everyone. Thanks for joining this session. We're going to discuss backend-related issues that affect front-end development and actually what can we do about this. So my name is Tomasz Ducin. I used to be a Python and Java developer, but at some point I decided that life is too easy and I need to do something about this, so I switched to JavaScript. And I'm still considering if it was a good idea, but let's see. Anyway, here I am. I'm doing trainings and I work for a Cybercom Poland company where I design architecture and implement enterprise-scale interfaces. And for over 3 years, I've been working for financial sector, and the experience I gained throughout the years is one I want to share with you today. So I would like to start with briefly recalling what is single-page application approach, what is the idea behind it. Then we'll go to the main point, backend-less development. So what is this? Why do we need it? What is it for? We'll discuss the technical details. Basically, how does that work? We'll analyze examples in Angular.js and Sinon.JS, and we'll finish up with automation because we don't want to do things manually. So back in the old days when we were doing not web applications, web pages, we were using the traditional approach. And that was that the user, which was using the browser, just entered a URL to open a page. The browser was shooting an HTTP request to the server. The server was processing, accessing all the data, processing routing, bundling those things together, and then rendering the templates, right? It also had to render all the HTML stuff, JavaScript, CSS, whatever. It was packaging the bundle and pushing it into the browser, right? If we clicked a link to go into a subpage, if we wanted to submit a form or just do whatever kind of interaction with the page, there was just another HTTP request that was sent to the server. The server had to do all of this stuff again, and there was another bundle that was pushed to the client. So basically, all this page is disposable, right? So it's like one-time application. So there was quite a lot of waste. Can you tell me what are the problems with this approach? What is wrong with this? Slow working. And diving more into details? Sorry? Because it was slow. OK, one thing. Anything more? Big requests. You mean? Yes, that's true. More? Come on. User experience, you mean? OK, responsiveness, yes. And also the fact that actually the server, the backend, should not be responsible for the presentation layer, right? It should deal with kind of different stuff. And also the response was a lot bigger, right? So it was also the network load, which was more stuff to be done. And if the server was processing the templates, right, it had to do a lot more work. So basically, if we could push it into the browser, then the browser will process the templating, right? So basically, the server will have less things to do, and this means less servers needed, less electricity costs, and so on. So for these reasons, this traditional approach is something that we basically don't want to work with anymore, right? Neither backend nor frontend people want to do traditional web pages. So for these reasons, somebody thought an idea of single-page applications. So basically, the difference is that when we access a page, we shoot the HTTP request, as we did, and we get the bundle, right? But we do it only once. And it stays in the browser until the very end. If you want to interact with anything, we just, the single-page application shoots an AJAX request to the server, which is REST API, REST-ish, quasi-REST, REST whatever, and it returns a JSON response, which this single-page application is reacting to. If we want to submit a form, if you want to access another page, we just send this small request, and there is a lot less to be done on the server side. So this approach is a lot better. Basically, all modern front-end things like Angular, Backbone, React, whatever, everything based on single page client-side web applications, right? We moved the template processing out to the client. So we made those two applications separate, actually. Everybody likes single-page application. It seems to be like a flawless solution. But the thing that many people miss is that if you benefit from something, you have to pay for this, right? You never get anything for free. And let me tell you a short story about that. So once upon a time, far, far away, there was a team of software developers. There were the cool kids on the front. They've been working with nice look and feel, user experience, responsive web design, and that kind of stuff. And there were the respectable gentlemen on the back end. They've been dealing with data scalability, transactions, persistence, and they believe that what they do is really important for the system. You might have spotted that there is a special guy here in the corner. He was working for the same company, for the same project for many, many years. Actually, he was always afraid to leave the company. So as people were moving in to the project and out of the company, he has gathered all the secret knowledge about the system. He knows all the magic numbers. He knows all the dirty hacks. And this made him the best fit for a solution architect. And due to the fact that he would never leave the company on his own, the board decided to make him one. So here he is. And it was just an ordinary day when one of the backend services collapsed. It's down. So the first thing that backend guys try to do is just to restart the service, right? They tried to do it, and the server fell down again. So they tried once more, and just several times, and it was going down right all the time. So they grabbed their fire helmets, they turned into a team of firefighters, they started to run all over the company, all over the office, trying to find what is wrong, who can help with the situation. And in the meantime, the front-end guys were trying to actually retrieve something from the server just to carry on with their work, but it was not working, right? So they had to do something. So they do coffee, like table football, this kind of stuff. When they came back and shoot their new requests, it was still failing, so nothing changed very much. By the end of the day, the backend was still down. And let's say that it was not one day, it might have been like 3 days. This happens in enterprise companies. And actually, that was not a big deal, that we're not feeling bad about this. It's quite a relaxing situation. But if we think about it seriously, then it's a big problem for the company, because the guys are getting paid, and they actually cannot do much constructive work, right? So what we can see here is that there is a tight coupling between the front end and the back end. I know that, we know that tight coupling term is used mainly in terms of design patterns. But if we take a look at the architecture level, then we see that we have exactly the same problems, right? We can see that the backend can work without frontend, but the frontend cannot work without the backend, right? So my question is, what is more important, frontend or the backend? It depends.
Because if you're working, for example, hybrid applications, they can work frontend without backend temporarily down.
Okay, but hybrid applications or progressive web apps, it's just one of many approaches, right? What is your opinion? If you were to choose, what is more important? I'm a front-end developer. That's why you talk so much. I'm pretty sure that you Java developers have a very strong opinion on that. Don't be shy. So basically, I know that this is a biased question, but if we think about it, if we try to understand the problem, then we can see that if we make one of the sides more important, then the other one is going to suffer from its problems, right? there are no perfect systems. So if our backend becomes unavailable, it's slow to deploy or whatever, and we make it the more important one, right? Then we will make the other side suffer. And this will mean like organizational problems and also financial costs for the project, for the company. So let me tell you one more story. The architect guy wanted to gather a meeting of the backend specialists, and the topic was that he doesn't like a JSON response of one of the requests, of one of the resources. So they asked, like, what is wrong with it? Why do you want to change it? And he said that the current shape of the JSON does not reflect what this resource actually is, right? He suggested that there might be a better JSON shape. They discussed that and agreed, like, right, you're right, we might change it. So they discussed what is the new design, who is going to implement it, and they implemented it, released, and bang. Application crashed. What was wrong? There's one thing missing. Sorry? Yes, exactly. They just didn't tell the guys that there will be a change, right? And they might get like undefined is not a function, whatever kind of problems. And the front-end guys then need to spend 2 hours to find out in the runtime what is wrong, right? So in enterprise, we say it's a bad communication, not to blame anyone. So what is backend-less development actually? In few words, this is just an approach to enable front-end development to be independent on backend, totally, right? So this is not about production, because having a front end that works without a backend in production would like not make any sense at all. But this is just during the development phase. Let's say that we're given 3 months for a project that needs to have some core services, enterprise layer, and the front end. And all of these guys have 3 months to finish. And if the front end needs the backend to be done prior, right? Then something is wrong here, right? Because these guys will have a lot less time to cope with this. So this is backend-less development, like in just a few words. Not to make a mistake with serverless architecture, which is something completely different. Serverless architecture is when we do a backend, but we don't want to concentrate on the backend services infrastructure. We just move it out to a cloud or whatever stuff. But we do have a backend, and we do implement the backend logic. And here, we want to concentrate on developing front-end without backend at all, right? Just for the development time. If we talk about this approach, then we need to introduce a good communication, right? So we need to specify what are we gonna share? Like, what are the requests? We need to do it prior the implementation, right? So front-end and back-end developers meet, they discuss what is the contract between front-end and the back-end, and they start working. My experience is that my team, the teams, like in the company I work in, we can create the entire solution, entire delivery in 90% of our time without having any backend at all. And we just spend 10% at the very end to synchronize with the backend. Like in the perfect world, it should be 0, but like there are always some like mismatches, right? So we need to just synchronize it perfectly. And this is quite cool because for this time, we are completely independent on all the unavailabilities, all the issues, all the breakdowns which are happening in the backend layer. And in enterprise companies, like you can have quite many of these. So if we're talking about the technical perspective of backend-less development, then first, the backend changes might force front-end changes, as we have seen right now. So this is one of the problems we want to address. The second one is that the backend needs to be implemented prior to front-end, because the front-end needs to talk to something, right? It has to have some kind of response to interact with. Of course, we might put like static JSONs into the front-end, but then we would need to remove them. So this is not a perfect solution, right? And finally, backends being unavailable. So this is a big time loss. There is one more thing about end-to-end tests. Does anyone know what is end-to-end test or have done this? Hands up. Okay, quite a few people. So in short, if you have unit tests, you can just pick JavaScript code or Java code or whatever and just test given certain methods to see if they return the results you expect or not. So this is just a small unit. If you do end-to-end tests, then you grab the whole application, right? Everything. You tell the URL you want to open in a real browser, and then you tell, open this page, then please click this link, then expect a pop-up to be filled with a form. You fill the form with data, you click submit, then you wait until the pop-up is being removed, the list of items is reloaded, and you assert that the new number of items is one more than it was before. So basically, like Selenium, like Protractor, and this kind of tools. Yeah, exactly. So basically, they need to have a real interface. It has to be deployed on some kind of web server. So if you want to do this, then this interface needs to talk to something, right? And now, if we have a really complex backend, especially one that uses some kind of core services that does not have their mocks or any kind of replacement, right, which would be very small and fast to deploy, then it turns out that if front-end developers want to run their end-to-end tests, then they need to deploy this first. If this takes, let's say, 1 hour or 2 hours, then the entire end-to-end test runtime for the front-end is a lot longer as well. So basically, we would like to be able to deploy, to run end-to-end tests a lot faster, right? Because if this takes 2 hours, then in practice, almost nobody will do it. And basically, this is a situation that we want to avoid. So let's carry on about. So you might ask, like, why do I need backend-less development if I do have a very good quality backend, right? So my experience with backend-less development approach is a project that is called PortalBank. It's a bank and user interface which has been deployed in over 120 Scandinavian banks. It's an Angular TypeScript application, well, never mind. And I learned that enterprise environment is a very specific kind of environment where there are some problems that do not exist outside this, this situation. So let me tell you about this. Can you see what this guy is doing in this picture? Yeah, he's painting the grass green. Who is not Polish in this room? Okay, there is one guy. So basically, in Polish, there is a phrase that to paint the grass green, which means to perform some actions which provide completely no value, right? So basically, this is what we do in enterprise companies. And nobody gets fired, and we are paid like quite well. So we can do this individually, and we can do this in teams. It depends on the company whether it prefers individual experts or Scrum teams. So the business perspective on why do we want to do backend-less development is budget-driven development. So a budget is a limited amount of money that might be spent in limited amount of time. So we are limited on both, let's say, things. We need to deliver something very fast, even if we don't have this backend, or even if there are kind of unavailabilities. Another thing is big distributed teams. Often, we don't work in one city, in one office, in one country. We might be working in different continents as well. And if, let's say, a team from, let's say, States is working on a backend, and a team from Europe is working on front-end, then it's really difficult to communicate what is going to be the communication, right? We need to make it like more clear and more transparent. And finally, backends being unavailable. This is also a business problem because it generates a lot of money loss. So these are the problems we wanted to address from the business perspective. And now I would like to ask you, we would like to mock our API. These layers are some kind of quite big simplification of web application. So at the very bottom, we've got the database, which is just something, you know, on server layer. We've got the server API endpoint. So this is basically the service, the REST service, which we are communicating to. There is the browser API. So basically, this is the JavaScript native implementation, which we are using from the browser. There is a framework like framework or library like jQuery, Angular, React, whatever kind of cool library your team is using. And we've got the application core. So this is our code, which is reused in many places, in many modules, like the core of the application. Finally, we've got the application modules. So this is like display a list of customers for the page and enable me to add like a new item into the list. And finally, we've got the graphical user interface. So these are all the buttons, all the scrolls, all the things that a user can touch and interact with. So the question is, how do you think, which layers does it make sense to mock? The framework. Browser API. Server API. The database, yes. Yeah. Obviously, the database is a very good idea to mock. However, this is just not covered within this presentation. But yes, I think that it makes sense to mock exactly those three layers. I think you are the first time, it's the first time that you have just told these ones correctly. So we're gonna go through all of these in a while. So. Technically speaking, backend-less approach is, first of all, delivering the data, and it depends on which level we decide to go with. Like, there are pros and cons of each of the approaches. But we don't want to have, like, you know, plain mock data, the same information being returned for each kind of the same request, for each request of the same kind, right? So we would like to introduce the behavior, right, to act dynamically on what we did before. And this includes interacting into whether we have get, post, put, delete kind of requests. If we want to introduce a timeout, right, for the mock, and also for the request parameters. So if we shoot, let's say, get customers/7 and get customers/113, we would expect to have something different, right? And especially if we get a list of an entity, of a resource, we add a new entity into the resource, and we refetch the list again, we would expect to have one item more, right? So that the end-to-end tests will pass. So we would like to have some kind of intelligent mocks, not just a stupid return this JSON from the file all the time again. And finally, we need the data generation for this. So we might use JSON Schema. Who knows what is JSON Schema? Hands up. Okay, so there is maybe 1/3 of the room. So basically, XSD for XML is just like JSON Schema is for JSON. So JSON Schema is just a meta definition of a JSON file. Like, it defines what can it include, what can it consist of, for data generation, for documentation, for data validation, and so on. And there is contract-first design to make, let's say, designing the communication of the REST API more transparent and more clear. So these are the things we'll discuss. So JSON Schema, just very briefly. This is an example of a JSON schema document. It says that a title is just some kind of documentation attribute. The type is an object. We allow these objects to have properties. First name, which is a string, last name, which is also a string, and age, which is an integer, that minimum value is 0. We also define that additional properties are not allowed, like nothing else than those three, and that required fields are first name and last name. So this one and this one has to be included in the document. An example of a document that conforms to this schema is first name John, last name Lennon, and because of he's dead, there is age 40. And another example is first name Paul, last name McCartney. So this is basically to generate, validate. Yes?
What is the case when we have two properties with last name and first name in a different way? When you pass while calling for first.
Could you repeat the first part of the question?
When you have two properties with a first name and a last name, two properties, for example,
Yes.
first person and second person,
Yes.
in an object, and you define require directly first name and last name. What is object is required?
I think
Property in what object? Yeah?
two properties,
Because
yes.
if you have a nested properties, you can have multiply last names and first names. And,
Well, basically, I'm not sure if I understand the question, but instead of object, you might have an array. Instead of a simple property, you might have a nested array, nested object, or nested kind of everything. If you create a JSON document with first name multiple times, then whatever kind of interpreter, whether it's, let's say, native JavaScript in the browser or kind of Java JSON parser, it will just throw an error before JSON schema is used at all. So basically, you can define whatever kind of shapes you want to define. But maybe we will just address this question after the presentation, if you're okay with that. So you can use many kind of tools to, many kind of like extensions to specify whatever kind of JSON documents you want. And there is a tool that you might use to generate massive amounts of fake data. So I will share the slides to this presentation, but just to briefly show you, we can define a JSON schema with name and email property. We can define also some kind of domain meaning, right? So that the name becomes a name and the email becomes a real email. And we just generate samples. This might work on the server side, but it can also work offline inside the browser with no backend communication. We can grab this thing and put it inside an array. So an array with from 100 to 200 elements instead of just an integer. We pass this object here, and we generate samples like this. So if we want to test the performance of a front-end interface when having, let's say, 2,000, 3,000 elements just to see pagination, performance, like just rendering WebKit stuff, and so on, we can just generate it massively like out of the box. If we want to add a new attribute, then we can just extend this definition here, right? Because if you wanted to add an attribute manually to all of these things, or write our own scripts that would update it, this would be like pretty messy to do. So this is just one of the example tools that allow you to generate the data automatically. So the first and most obvious ways to mock an API is probably the server API endpoint. Most of you are backend developers, so this should be pretty obvious for you. So there are two ways mainly to do it. You can either write your own API, which is kind of manual work and not like pretty expensive to maintain, or you can use one of these tool stacks like Swagger, API Blueprint, or RESTful API modeling language to do it for you. Basically, what we do in those tool stacks is that we define a contract, right? And we start doing contract first design. Who is doing this already? Here, okay, just a few people. So when I ask what is more important, the front end or the back end, the answer I think is the right one is that neither of them, none of them. The contract should be the most important one. So basically, the contract is just a text file which includes the URLs and the HTTP methods of the resources we have. We define also the status codes like 200 OK, 404 not found for certain cases. We define the content types, whether it's JSON or something else. The HTTP headers, if we do have any kind of custom headers in our application. And of course, the content itself. So basically, this might be a JSON schema, for instance. So we specify this, this contract, write down a file with a very specific syntax, like whether it's Swagger or Ramal or API Blueprint, they have their own syntaxes, file definitions for this. We write this file down, save it in the repository so that it becomes available in continuous integration, right? And this can be used by many automates. So we can automate generating documentation, we can automate generating mock data, we can automate generating integration tests for the backend, right? To see if our implementation conforms to this document. So basically what we do at the very beginning is that front-end and back-end developers meet. They discuss what is the front-end, what is the contract, right? What is going to be the communication between them. They write it down, they store it in this repository, and this becomes the single source of truth from this moment. This is the most important. If they need to change something because they found out that the core service needs like a different attribute, then it's fine, but they need to shoot a new commit to the repository to run over all the automates again, right? This is really cool because it's transparent. Everybody can access the documentation generated from this. It's online all the time. If there is a new developer that comes into a team, then it's like he just can access the link to see what are the resources in the system. Like he doesn't need to browse the code. And also, if there is anything wrong with the backend implementation, we automatically get notified in the continuous integration thanks to it. So all those three tool stacks, they have their pros and cons. They're not perfect. I think it will take maybe 2 years or 3 years to make them really powerful. But I think this is surely the future that we will go in, because doing REST endpoints, doing REST resources is not very different from doing CRUD, like create, read, update, delete. Right? This is something that can be automated, or at least testing this and documenting this. These are the tasks that we can just squash and let just a platform do it for us. So this is the server API endpoint mocking. Another approach is to mock the browser API. So basically, we want to hack native JavaScript inside the browser. This means that if there is a request coming from the user through all these layers, it goes to the browser API, it goes aside, fetches the data, and goes back, bubbles up. It means that the AJAX does not go out from the browser. It can be purely offline. Even if you have no internet at all, everything will work fine. You can demo the application to business guys, and everything works perfectly. So how do we do it? In JavaScript, we've got the thing that is called XML HTTP request. It's just a native JavaScript object that handles all AJAX. And what Sinon.JS is doing, Sinon.js is a testing library that has some kind of mocking, stubbing features, including the one that we will see in a moment. What Sinon is doing is it grabs the original object and it replaces it with its own fake implementation. So basically, if we shoot an AJAX request to any kind of URL, normally it would go outside the browser, but when this object is replaced, when it's hacked, it will be used, it will do the things that it's configured to do, and it will just behave normally, so that whatever you're using on top of that, like whether Angular, jQuery, like whatever you use, or even plain JavaScript, everything will work smoothly, right? So we can just hack JavaScript. I've got a project which includes the very minimum amount of code that might be used, so I'm going to share these slides. You can both see the online demo and the minimum code, so we don't have time to go through this one. We'll just take a look at the code a little bit. So we create the fake server, sinon.fakeserver.create. It's just an object which has a magical method respond with. So we define that for given URL and for given HTTP method, we will return a triple. So HTTP status like 200, everything is okay. The headers, if we want to return any kind of custom headers in the response, and the data itself, right? So this is an easy case when we want to have static data. Then in a while we will discuss dynamic data. So a bigger file that displays how to use Sinon is, at the very top, we've got value, which is, let's say, a collection of some kind of objects which we're going to use. We've got the fake server wrapper. So it's our object that has the initialize method and the restore method. It's just for us to make it easy to turn on and turn off the server. So we create the server and we tell it to respond to get customers with 200 content type application JSON, and we want to stringify the value from here. So basically, we are using JavaScript scopes to access the data, right? Okay, so this was Sinon. An alternative to hacking the built-in JavaScript is to use a framework layer. So Angular.js is just one of the examples. I believe that whatever kind of library or a framework that has its own model layer should get bundled with such a solution. So the idea is really similar. We have a HTTP backend service. It's just an Angular building block, a service. So we have a when method, which accepts the HTTP method, the URL, optionally the data, like get parameters, post parameters, and so on, and optionally the headers. And what we do is that we respond with a triple again. The difference, there is no difference in the logic, there is just difference in the syntax. So if we want to have like short methods, instead of this, we can have when get, when head, when delete, when post, and this kind of stuff. But this is when we have like static data. If you want to make it dynamic, then instead of responding with just 3 parameters, we respond with a function, right? Which is with a callback. JavaScript will look if the first parameter is a function, and when this request is being called, then it will just invoke the function. So we can access all the parameters here, like if it's get, if what kind of URL is this, what parameters were passed to this request. It can do any kind of processing here, and this processing might include updating the data from the scope, right? So that we can add an element to the collection, so that the next get will return the new collection, right? And of course, we return the same triple of data. An example of usage. So here we've got Angular module. This is just some boilerplate. We define a resource on Angular module model level. We define a fetch so that when we click, the function is invoked. So we want to access event ID events/6. But this is just some boilerplate. And let's go to the mock part. So we've got some data. Again, we're going to interact with this collection. We've got some 4 magic lines of code that does the right thing. Never mind. We just need to include this. And finally, for our module, we have a function that HTTP backend when get /events/6 respond with the data. We can make it a function. We can dynamize it with a regular expression. And of course, we can have lots of these to enable multiple resources, get, post, put, delete, head, and all kind of HTTP requests. So this is useful, but it would be really difficult if you wanted to have like one big file to maintain all of this. So we would like to automate it, right? So we would like to let the platform generate it for us so that it's like the most convenient as we can do it from our side. So let's get to the last section. It's a simplification, but let's say that our application gets minified into app.js file, right? So this is the file that we will use in our HTML document anyway. And what we want to do is optionally include the mock.js file, which includes all the mock definition, or not. So either we want to build a production-ready version, or just development mock version, right? So we will discuss how to build this mock.js file. Okay, so first, what the mock.js will include is the mock data, right? So we have seen the JSON schema or any kind of alternative. You want to have the JSON files. These will be just the static JSON files. You can regenerate them if you want to modify the content manually, automatically, whatever. So the mock data. The second thing is the mock logic. So if you want to cover a resource with all kind of REST operations, then we need to cover it with functions for applying get collection, get item, post item, put item, delete item, any kind of REST HTTP methods that we want to enable interacting. So at the top you can see that there is mock data require. It means that we will load this file from an external file, right? But it means that all these functions will interact with the content of this all the time. And finally, the dependencies, right? So HTTP backend for Angular, fake server for Sinon, or whatever kind of alternative library you're using. So we need to include all those three, and this is how we create the mock.js. And of course, on the, let's say, low level, we are using the scope. That until we refresh the page, all the changes that we applied will be stored, right? Until the very end, so that we can have intelligent mocks and we can do end-to-end tests. So if we have multiple files and we want to bundle them up, there is quite a simple pattern in modern JavaScript in Node.js that is called abstract syntax tree. So we give an input file and it scans, analyzes all the require statements. Like here is require B, so it means that it will go to b.js. B.js has a require D, so it will go to d.js. This require C will go to c.js. So there are tools that will scan all the dependencies of the files. It will do a bundle, right, that will contain all the thing. And it enables a feature that this will work in Node.js out of the box, but if you use things like this abstract syntax tree, you can use it also in the browser. So you can squash multiple files into one file and use it in the browser, just like we want to have this mock.js file. So it's an abstract syntax tree. And the tools that do it, it's, for instance, Webpack and Browserify. So they use the native require function. They grab all the loose files, and they just create a bundle, so it's a single file, that knows how to process the require function, right? So this mock data, mock logic, and dependencies put in this mock.js bundle, they will know how to interact with the functions of the mock behavior, of the data, and so on. So we've got the app.js, we've got the mock.js. So the last thing we do is whatever kind of automation tool we're using, we will create a new flag that is -- mock. If you want to create all this mock job or not, right? So if you're using mocks, then we would like to, if we want to create mocks, we will use it for sure in development, and we might want to use it if you want to do end-to-end tests, but just only the user interface behavior. But there are situations, of course, when we don't want to have mocks. So this is basically the integration. If you want to see how does our interface work with the real backend application, and of course the production, right? So in CI, whether it's Jenkins, TeamCity, or whatever you use, you will just define that it might be -- mock or just no flag for this. So if there is just one thing I would like to remember, you to remember after this presentation, is that independent clients make all the parts of the project benefit, both the front end and the back end and the business, like everybody. So this is all I've got for today. Thank you very much.
Dziękujemy.